Okay, so we're going to have a look at question 2. And we need to determine whether each set is closed under the following binary operation. Okay, so for the first one, we have the group of the positive integers defined under the binary operation star, where star is, so x combined with y is equal to x factorial multiplied by y factorial over xy. Okay, so we need to determine whether this set is closed. Okay, closed meaning that you can combine any two elements from the set and you will obtain a third element which is still a member of that set. Okay, so let's consider this binary operation. Okay, so by the definition of factorial, we see that this is equal to x multiplied by x minus 1 multiplied by x minus 2, and so on and so forth, all the way up, all the way until we get to multiplied by 1, and then we're finished. Okay. Again, this is multiplied by y factorial, which is the same thing. It's y multiplied by y minus 1 multiplied by y minus 2, all the way until we get to multiplied by 1, and then we stop. Okay, and all of this is being divided by xy. Okay, so what can we see happens here? Well, we see that x divided by x is 1, so let me just put that, let's put that in green. X divided by x is 1, y divided by y is 1, so we can just cancel them out. So we can therefore say that x combined with y is equal to x minus 1 all the way up to 1, so essentially that's x minus 1 factorial multiplied by y minus 1 factorial, yeah, because here we have y minus 1, y minus 2 all the way to 1, so essentially that's just y minus 1 factorial. Okay, y minus 1 factorial. And we know that the positive integers are closed under multiplication. Okay, so if you take any positive integer, so here we're never going to get a negative because we're always going to stop at 1, right? So this is equal to x minus 1, x minus 2, and we're going to stop when we get to multiplied by 1. Okay, the same thing for y as well. So we're never ever going to get negatives here. Okay, so we can have a little statement saying the positive integers are closed under multiplication. Hence, this is a group under the binary operation. Okay, and this group is closed. Okay, so let's have a look at part B now. Okay, so part B, the binary operation. So sorry, the group is the real numbers under the binary operation star, where x combined with y is equal to the square root of x plus y. Okay, so already instantaneously we can see there's a few real numbers you can put in here. There's a lot of real numbers you can put in here that would break the property of closure. Okay, so let's take, for example, x equaling 0 and y equaling negative 5. Okay, so we'll see that x combined with y is equal to the square root of minus 5. Okay, and that is I root 5. And since I root 5 does not belong to the real numbers, we can say this group does not obey the property of closure. Okay, so the real numbers are not closed under this binary operation. Okay, so let's now have a look at part C. What have we got for part C? Okay, so we have the odd numbers now. So we have the following group of the odd numbers, again under the binary operation star, where the x combined with y is equal to a squared b. Oh, well, x squared y. Okay, so a few different ways to do it. The way I kind of thought of is we can just say, since x and y must be odd, okay, we can say let x equal 2a plus 1. We can say y equals a 2b plus 1, where a and b both belong to the integers. Okay, definitions of odd numbers right there, and we can literally just sub them in. Okay, so we can say this is equal to 2a plus 1 squared times by 2b plus 1, and I'm probably not going to do it here because it's running out of space, and it's It's quite elementary. So just expanding out this bracket and then multiply it by 2b plus 1, and you'll show that you will have, you will end up with, we'll say, p plus 1, okay, where again p belongs to the integers and p is just going to be in terms of a and b. Okay, so we're just going to have a big function in terms of a and b, and then we're going to have plus 1. Okay, so this will be odd, so we'll show that the product of these two things is going to be odd, hence the odd numbers are closed under this following group binary operation, excuse me. Okay, and last but not least, we'll do part D, which is the complex numbers, again under that following, the same binary operation, and it's the, so we have x combined with y is equal to the magnitude of x plus the magnitude of y. Okay, so again we can see that the magnitude of any complex number is going to be a real number. Okay, so we could even just say, we can say let x equal a plus bi, and we can say let y equal c plus di, where again a, b, c and d are all real numbers, and we can show that the well, we know that the magnitude of x is equal to a squared plus b squared, and then the magnitude of y is again just going to be c squared plus d squared. So we know that the magnitude of x plus the magnitude of y is simply given by a squared plus b squared plus c squared plus d squared, and that itself is a real number because we know the real numbers are closed under multiplication and addition. Okay, so we know that the complex numbers under this following group operation, this binary operation, are closed. Okay, so that's that, and thanks very much for watching. I hope it helped.